From the moment we looked up at the stars, we've asked the same questions. Where did we come from? What is the universe made of? And where is it all going? Despite all our scientific advances, satellites, telescopes, and supercomputers, there are still secrets the cosmos refuses to give up. Today, we're diving into the 5 biggest mysteries that continue to baffle even the smartest minds on Earth. Part 1. Dark matter, the invisible force. Let's start with the most glaring mystery, dark matter. Galaxies spin too fast. According to Newton's laws, they should fly apart like loose carnival rides. But they don't. That's because something unseen is holding them together, an invisible glue we call dark matter. Physicists believe dark matter makes up about 27% of the universe, yet it doesn't emit, absorb, or reflect light. We can't see it, we can't touch it, but we know it's there because of how it bends light from distant stars and influences gravity on massive scales. For decades, scientists have tried to detect it through underground experiments, particle colliders, and telescopes. They've proposed ideas. Maybe it's WIMPs weakly interacting massive particles, or maybe it's axions, tiny hypothetical particles. But every time we look, we find nothing. It's like chasing a ghost that can pass through walls and our instruments. So what is dark matter? A new kind of particle, a flaw in our understanding of gravity. Until we solve it, we're missing a huge chunk of the cosmic puzzle. Part 2. Dark energy, the unstoppable push if dark matter is mysterious. Dark energy is downright much. In the 1990s, astronomers were measuring how fast the universe was expanding. They expected to find that the expansion was slowing down, but they were wrong. Instead, they discovered it was speeding up. That shouldn't happen. Gravity is supposed to pull things together, yet something is pushing everything apart faster and faster. They named this unknown force dark energy, and it's not just powerful, it's everywhere. In fact, dark energy makes up 68% of everything in the universe. Let that sink in. The universe is mostly made of something we don't understand at all. Some say it's a property of space itself, a constant energy embedded in the fabric of reality. Others believe it might be a new force or field we've never seen before. What we do know is that it controls the fate of the universe. Will space continue to expand forever, growing cold and empty? Or will it rip apart galaxies, atoms, even space-time itself? Only dark energy knows. Part 3. Hubble tension, the cosmic conflict. Here's a strange one. Hubble tension. It's not a sci-fi movie title. It's a very real scientific problem. Astronomers have 2 major ways to calculate how fast the universe is expanding. This rate is called the Hubble constant. One method looks at nearby stars and galaxies. Another uses data from the early universe, the cosmic microwave background, measured by satellites like Planck. But here's the issue. The numbers don't match. Local measurements give us a faster rate of expansion. Early universe measurements give us a slower one. The difference isn't small. It's enough to suggest we might be missing something fundamental about how the universe works. Some physicists suggest there's a hidden particle affecting the results. Others think our understanding of time or space might be flawed. Either way, the tension between these measurements is growing, and it may point to entirely new physics. Part 4. The beginning and end of everything. We all know the universe began with the Big Bang, right? Well, sort of. The Big Bang theory explains how the universe expanded, but it doesn't explain what caused the Big Bang, or what came before it, or whether before it even makes sense in this context. Some physicists propose the idea of a multiverse, an infinite sea of bubble universes, each with its own laws of physics. Others believe in a cyclic model, where the universe expands and contracts over and over in an eternal rhythm. And what about the end? Will the universe freeze into stillness? Will it collapse in on itself in a big crunch? Or will everything be torn apart by runaway expansion in a big rip? We simply don't know. What we do know is this: the cosmos has a beginning, and it will have an end. But the story in between is still being written. Part 5. Where is everyone? The Fermi paradox, finally. The question that keeps us all up at night. Where is everybody? With billions of stars in our galaxy, and billions of galaxies in the universe, there should be other intelligent life out there, right? This is called the Fermi paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" Maybe life is rare. Maybe civilizations destroy themselves before reaching the stars. Maybe they're watching us and just don't want to be found. Or maybe we're truly alone. Despite decades of listening, scanning, and searching, has yet to hear a single confirmed alien signal. Are we the first intelligence in a silent universe, or just one voice in a cosmic choir we've yet to hear? Until we find a signal or send one that's answered, the mystery remains. What it all means, here's the truth. We live in a universe we don't fully understand. We walk on a planet powered by physics we haven't yet mastered. We look up at the stars, asking questions older than time itself. And maybe that's okay, because mystery is the fuel of science and wonder is what makes us human. So the next time you look up at the night sky, remember there's still so much more to discover, and you're part of that journey.